Welcome to the Occupational Safety Leadership Podcast, episode number 52. In this one, we are continuing our journey in process safety management, and we will focus on mechanical integrity. Let's get started. So, the PSM standard found under 29 CFR 1910.119, and in this one with mechanical integrity, it's almost all about inspection and testing requirements. When you're installing it, how are you making sure that something is not leaking? We want to do everything we can to make sure something doesn't fail. We also want to make sure that we're inspecting and testing things to make sure that if it's getting to that point, and of course that's really difficult to judge. We're taking something out of service. We're planning for activities to happen. We're not just letting something happen. But let's go ahead and continue on then. So when we look at the standard itself, when it talks about pressure vessels and storage tanks, and I'm just going to talk in a very general global stance. We're not going to get into all the ASTM standards and ASME standards and all that stuff. But so pressure vessels and storage tanks, you have to have a inspection and testing program for the piping and valves, relief and vent systems. You can also have devices as part of this too. Emergency shutdown systems, pumps and motors. And then when we look at the controls, the monitoring devices, the alarms, the sensors, the interlocks, everything is going to fail. So at some point we have to go back and make sure that we're inspecting, we're testing, we're making sure that we're just operating it as safe as we possibly can. Go on to the next slide here. Part of the mechanical integrity program is that we're going to have written procedures. We're not just going to wing it, and a pump is not a pump, and because you have carbon steel, you have steel, all of the different grades out there. Does it have to be chemically resistant? Does it have to be explosion proof? I mean, there's a lot of things to sit down and take into account, and that's why we're going to have everything written down so we can go back and 100% verify before we're ordering, of course, obviously parts too. We're going to put the right valve in the right place, right motor in for the right motor. We don't want to cause that incident by accident when we really think we're trying to do the best job we can. We're also going to have training for the people who are doing maintenance on our process vessels, piping, pumps, and motors, and all that stuff. Then we want to train them on the hazards. We also want to train them on performing the tasks in a safe manner. And when we think about lockout, tagout, confined space, how do you go back and isolate a system of process piping? You know, you may have a leak in the process piping and you're going to close it on both ends and go back and fix something. Have to have these systems ready to go so that you don't just have issue and then say, so now what? We really didn't plan for it. We really didn't train anybody. We're just going to kind of wing it and see what happens. Go to the next slide here. When you look at inspection and testing, you have to follow recognized and generally accepted good engineering practices. And this is where we're going to go back and look up as many of the standards that we can find out there then. So ASTM, ASME, they all have really good standards then out there. And when we go back and look at this, we want to look at the frequency of inspection and test to make sure that everything is consistent with the manufacturer's recommendations. So this is where we have to actually sit down, read, and understand the manual. If it says something like on the process vessel itself that you should do a thickness test every single year to make sure that it's not getting to the point that it's eating out, it's corroding the steel, it's corroding something inside, which means you got to do it every year because they're saying it needs to be done on a yearly basis. You just can't install it and say, well, that costs some money, so why don't we just think about it when something fails or when something breaks, we'll just go back and do all this stuff too, which is a technique as long as it's done within that year. You gotta follow those manufacturing, the recommendations and good engineering practices. Also, your maintenance people are fantastic sources of knowledge If they think that it needs to be inspected more often, follow their recommendations. They are the experts at working on this stuff. We can write great procedures, but if we don't have the input from these guys for them to say, yes, this is actually a real procedure, a real way of how we do things, they have a lot of that operating experience out there. When we look at the next slides, we also have to go back and document the inspections. We just can't say like, yeah, we did it on this day. You then have to say, this is exactly how we did it on this day. This is exactly how the standard that we used. Maybe there's a checklist, maybe testing procedures, whatever that we do. And then here's the results of the inspection. We just can't say, yeah, we did it on May 10th. Well, that's awesome and great, but you didn't really say anything else on there. Equipment deficiencies. So the employer must correct in a safe and timely manner. So that doesn't mean, oh, it's unsafe, but we really got to keep on running to make those numbers. When something is unsafe, you take it out of service as quick as possible. And that's why when we get to this next slide here, we look at how we're going to have adequate spare parts on hand. We're going to have the maintenance manuals, we're going to have equipment, we're going to have pumps, we're going to have motors. You can actually run something to failure. That is a strategy that some companies have used out there. I think it's a super poor strategy, super unsafe when it comes to process safety management, but I do know that it does happen. So let's sit down and change gears a little bit and talk about quality assurance then. So now that we know the pumps and the motors and the piping and everything else that we're going to do, when we sit down and fabricate this, we have to go back and make sure that we're doing it to good engineering standards and that it's consistent with the design specifications. This is where when we go back and we look at our P and IDs and our blueprints and all that kind of stuff, we're following 100% what's written down. We're not just winging it and saying, well, we were going to put in a gentle elbow, but we just didn't have that piece on hand, so we just put in a couple of 90s in there. You got to put down exactly what's on the blueprints, drawings, design specifications, because all that is checked before the ground is even broken. It's double checked to make sure that all the good engineering practices are being followed. And that is it for episode number 52. In today's episode, we talked about mechanical integrity for process safety management. My name is Dr. David Ayers. Thank you for joining me today and have a safe day.